Okay, in the previous lecture, we have seen that d stands for the derivative with respect to x. And we have observed that d raised to m into d raised to n will give you d raised to m plus n. We have also observed that the kth derivative of e raised to mx will give you m raised to k e raised to mx. So this is what we have observed by taking first derivative, second derivative and third derivative and then writing the general result, which is usually done by induction. In the next part we did that if I take a polynomial fd, which is a to d square plus a1d plus a naught, then we have observed that fd e raised to mx turns out to be fm e raised to mx. This was also done in the previous class. So let us now move ahead. So let's write a note now. We know from the above result that fd e raised to mx is equal to fm e raised to mx. Hence, if m is root of polynomial fm, then e raised to mx is solution of differential equation f dy equal to 0. Now what is the meaning of this note? So this result we have just observed in the previous class, which is mentioned above. Now let us try to understand this particular note. So we will take one small example. Now I will consider a differential equation. So consider d2y by dx square plus 5d by dx plus 6y equal to 0. So this is a differential equation and I am trying to find the solution of this differential equation. To do this, I will use the above note. Now how will I do this? So first, this is actually very simple. Once you understand it, is very simple. So first I will write this as, so I will say solve. So first I will write this in the notations of capital D. So what does this become? d2y by dx square becomes what? Becomes d square. D square is this part. Y plus 5 dy plus 6y equal to 0. This means that d square plus 5d plus 6y is equal to 0, which is looking like, which looks like f d y equal to 0. This is your fd. Who is fd? where f of d is equal to, so I'm not looking at y, okay, omit y. So what is f d equal to? D square plus phi d plus 6, okay. If ft is this, what is fm equal to? Just replace d by m. If I just replace d by m, what will I get? I'll get m square plus 5m plus 6. Okay. Now once you get what is fm, and if you equate this fm to 0, if you equate this fm to 0, if fm is equal to 0, that is m square plus 5m plus 6 equal to 0. This equation is called as auxiliary equation. This equation is called as what? This equation is called as auxiliary equation. So let me write it. Auxiliary equation. Okay. So far I have done nothing. I have just taken that differential equation. I have converted into the language of capital D. From that I got FD, means I have just removed the y part from that. Y I have just removed from this thing. And then I'm replacing this d by the derivative d by some alphabet m, where m is a variable now. And I'm getting fm, and that fm is made equal to 0. And then I've got this equation. This equation will be called as a auxiliary equation. I've done nothing. Now what are the roots of this equation? So clearly the roots of this equation are what? Let me write. The first root is m1. What is the first root? M1 is -3, and the second root is what? The second root is -2. -3 and -2 are the roots, right? This means that what is f of m1? If I substitute this root in this particular f in this, I'm going to get 0 because the root satisfies the equation. Similarly, what is f of m2? F of m2 will also become equal to 0. What is m1? M1 is -3 and m2 is 0. M2 is -2. And then I will go to the equation that I have obtained in the note. What is a note? What is
Sir,
that?
plus 2 plus 3.
Plus 2 plus 3 roots. Roots are -3 and -2. M plus 2 and m plus 3 are the factors. So f of m1
Yes,
is
sir.
so f of m1 is 0 and f of m2 is 0. Okay. So now when I go to this particular equation, okay, f d y and blah 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 whatever. Let me write this for m1 and let me write the same equation for m2. So I'm going to get f d e raised to m1x is equal to, what was that? Is it fm e raised to m1x? So I'm just writing this fm1 e raised to m1x. And what about here? Fd e raised to m2x is equal to f of m2 e raised to m2x. But I know that f of m1 is 0. So this entire term has become 0. F of m2 is also equal to 0. F of m1 and f of m2 are 0. So this is 0. So what is remaining on the left hand side? F d e raised to m1x is equal to 0, and f d e raised to m2x is also equal to 0. What is m1? This means that f d e raised to -3x is equal to 0 because m1 is -3, and f d e raised to -2x is also equal to 0. And this means that, now look at this particular thing. Look at this particular thing. This means that what is fd? Fd kya tha? Fd kya tha? Fd was d square plus 5d plus 6, right? So this means that d square plus 5d plus 6 e raised to minus 3x is equal to 0, and d square plus 5d plus 6 into e raised to minus 2x is also equal to 0. And this, if I compare with the original differential equation, what was the original differential equation? Look at the original differential equation. The original differential equation was this in terms of capital D, right? So if I compare it with the original differential equation, it means that let me write here, original differential equation is d square plus 5d plus 6 y equal to 0, and d square plus 5d plus 6 y equal to 0. So this means that y should be how much? If I go on comparing, I'm getting that y should be e raised to minus 3x and y should be e raised to minus 2x. So this means that e raised to minus 3x and e raised to minus 2x both will serve as the solution of the differential equation. Therefore, e raised to minus 3x and e raised to minus 2x are solutions of the given differential equation. And once we know that if you have two solutions, if you have one solution y1 and if you have another solution y2, you can take a linear combination also. And therefore, what is the general solution of this differential equation? You can take a linear combination also. So this means that y is equal to c1 e raised to minus 3x plus c2 e raised to minus 2x. This will be the, what are C1 and C2? C1 and C2 are constant real numbers. So this means that this particular thing is the general solution of the given differential equation. What was the differential equation? D square y by dx square plus 5dy by dx plus 6y equal to 0. So this is the way that we obtain the general solution of the differential equation. So the crux of the story is that if you give me a differential equation, okay, if you give me any type of differential equation with constant coefficients, I will immediately convert it into the language of FD. From that FD, I will find out what is FM. From FM, I will find the roots. As soon as I get the roots, minus 3 and minus 2, I will now not do any such thing. I will say that this is always there. And I will directly from this minus 3 and minus 2, I can write the solution as c1 e raised to first root x plus c2 e raised to second root times x. So this will be the fastest way to reach the solution. That is our target. Okay, so let me take one more exercise. I hope you have copied all the material over here. I'm moving ahead. Let us now quickly solve the next question. So solve or find the general solution. Rather, I will say find the general solution of, I want to do it as fast as possible. Okay, so d square y by dx square minus 4y is equal to 0. So solution, what is the solution? I will first write it in the terms of d square y minus 4y is equal to 0, and therefore I will get d square minus 4y is equal to 0, and therefore what is this is nothing but representing what, f dy equal to 0, and what is fm? Fm is m square minus 4. And if I equate m squared minus 4 equal to 0, this becomes the auxiliary equation. And what are the roots of the equation? M squared equal to 4. So this means m should be 4 and plus minus 2. So the two roots are plus 2 and minus 2. I will label them. M1 is e raised m1 is 2, and the second root is minus 2. And therefore I have got two different roots, and therefore what is my general solution? If I get two roots, I'm going to get y equal to c1 e power m1x plus c2 e power m2x. This is what How this came? This came because we have observed something already before, that this always goes true. So this is that is the base. This is the base of that thing, and therefore my quick answer is that y is equal to c1 e power 2x plus c2 e power minus 2x. Okay, so this is the quickest way that I'm going to get the solution. I remember in my 12th standard, we used to be they used to give us this, and they used to ask us that is this what differential equation will be formed using if this is the solution, and then we do the derivatives and we try to manipulate and we try to find the differential equation, and that differential equation will turn out to be like this. Okay, now as we know that once you give me a differential equation, this is going to be the solution. I hope you understand that if you are given, suppose I am given in that y equal to c1 e power 2x plus c2 e power 3x. Okay, and if I want to find a corresponding differential equation, what am I going to do? I know that therefore the roots are 2 and 3, and therefore what must be the factors? The factors must be m minus 2 and m minus 3. This is the auxiliary equation, and this is m square minus 5m plus 6 equal to 0, and this is fm, right? And therefore what must be the corresponding differential equation for this? It must be d square minus 5d plus 6y equal to 0, which is the same thing to say that d2y by dx square minus 5dy by dx plus 6y equal to 0. So this y equal to this is a solution of this differential equation. This is what the quickest way. Vice versa, if you are now given this, I have also told you how to write the solution in the fastest possible way. So let's write a question. Now one care has to be taken when we are doing this particular thing. Now here at the very initial level, what I am going to do is I am going to take only those polynomials. I'm going to take only those auxiliary equations which is having special type of roots. What is the speciality in the roots? That the roots are different. In mathematics, you don't say different, you say distinct. The roots must be distinct, and not only that, the roots must be real roots. It may happen that when you take this auxiliary equation m square minus 4 equals 0, it may happen that you may get repeated roots. Okay, then this particular solution will not work. So we have to split ourselves into different cases, right? What are the types of roots? Basically, the type of roots are only two types of roots, either real or complex, right? So I will split two major cases as real and complex. Then after making the two major cases of real and complex, is there any complication inside here? Yes, there is a complication. Either the roots are distinct, तुम्हें सब अलग अलग roots मिलेगा, या you will get the roots as what? Repeated. The same thing here, distinct and repeated. So for every particular thing we have to use a different formula for the general equation. That is what we are going to study. What will happen if the roots turn out to be 2, 2 and 3? Then how will I write this general solution? So इसको थोड़ा सा modify करना पड़ेगा. Okay, what will happen if the roots are complex? Suppose the roots come out to be 2 plus 3i. Then what will I do? तो इसको भी हमें change करना पड़ेगा. We have to write the new formula. The simplest and the basic version of this formula is that if the roots are real and distinct, then you have to write it in this particular fashion. Let me take one more example. Find the general solution. d2y by dx square plus 3 dy by dx plus 2y equal to 0. Okay, so solution, what am I going to write? this particular differential equation can be written as d square plus, see I'm pulling out a y immediately in the first step itself, d square plus 3d plus 2y equal to 0. So this is your fd. Okay, see I'm reducing the number of steps now, and therefore what is the auxiliary equation? The auxiliary equation is fm equal to m square plus 3d 3m plus 2 equal to 0. And what are the roots of this particular equation? The factors are m plus 2 and m plus 1, and therefore the roots are what? Therefore the roots are m is equal to minus 1 minus 2. You can also write minus 2 minus 1, koi fark nahi padne wala. So these are the two roots, and what is the speciality of these two roots? They are real and distinct. Okay, we will start writing now what is the nature of the roots so that my solution will accordingly change. So what is this? Therefore, what is the general solution? Therefore, the general solution is given by y equal to c1 e raised to m1x. This is your m1 and this is your, let me write, these are your mi's, where I is 1 and 2, c1 e raised to m1x plus c2 e raised to m2x. So my solution is c1 e power minus x plus c2 e power minus 2x. If we have changed the positions of minus 1 and minus 2, you will get c1 e raised to minus 2x plus c2 e raised to minus, which is the same because constant है c1 and c2. So this is the general solution of this particular thing. Okay, let me take one more example now. Find a differential equation. Find a differential equation which has a solution y equal to c1 e power 2x plus c2 e power 3x. Okay, so we are again you're going to use our knowledge that this means that m1 is obviously 2 and m2 is how much? 3, and therefore what are the factors? The factors are factors kiske? Factors of auxiliary equation, right? Auxiliary equation are obviously m minus 2 and m minus 3 equal to 0. This is the auxiliary equation. So what is the auxiliary equation? I will denote auxiliary equation by AE henceforward. So it is equal to m square minus 5m plus 6 equal to 0. This is your fm, and therefore what is your differential equation? Kya hona chahiye? The differential equation is always in the format of fd, the derivatives y is equal to 0. So this means that d square minus 5m 5d plus 6 y is equal to 0, and this means that the differential equation is d2y by dx square minus 5 dy by dx plus 6y is equal to 0. So this is the differential equation whose solution is what? Whose solution is c1 e power 2x plus c2 e power 3x. We take this exercise. So find the general solution of d cube minus 7d plus minus 6 equal to y equal to 0. Okay, so how am I going to solve this particular thing now? So what is the auxiliary equation? It is already given, so it is a third order differential equation, which is d cube y by dx cube plus minus 7 dy by dx minus 6y equal to 0. So we are basically looking at this differential equation. So what is the auxiliary equation? Fm equal to m cube minus 7m minus 6 is equal to 0. Okay, now if I observe one thing, that if I put how will I find the roots of this particular cubic equation? So if I put m equal to 1, if I just try to guess the root, if I put m equal to 1, I'm going to get what? 1 minus 7 minus 6, which is minus 6 minus 6, pretty close enough. Minus 6 and minus 6 is not equal to 0, it's minus 12. So this is obviously a bad root. This is not a good guess, it's a bad guess, it's not a root. But if I put m equal to minus 1, by taking this guess that they were very close, I will get that minus 1 ho jayega, and this 7 and minus 1 will become, this will become minus 1 plus 7 minus 6, which is becoming plus 6 with a minus 6. So that is equal to 0. So this means this guess is pretty good. So this means that m equal to minus 1 is a root of this cubic. So when I have a cubic equation, what I will do is I will first try to make a guess, okay, by looking at the coefficients. If you directly add the coefficients and if you're getting 0, this means m equal to 1 is a root. I hope you know this trick. Okay, suppose suppose you're having a cubic equation which is like this. Do you observe that if you simply add the coefficients 1 minus 7 plus 6, so ye 0 ho jayega. This means that the coefficient, that m equal to 1 becomes a root of that particular thing. So well, here m equal to minus 1. So first root I've got. Now the second and the third root I will go follow by my synthetic division method, minus 1, and this cubic equation, which is m cube minus plus 0m square, I'm writing all the coefficients, minus 7m minus 6. I'm going to write the coefficients in the table. So I'm going to get a 1, a 0, a minus 7, and a minus 6. So this one is carried down as it is. So this is 1. 1 into minus 1 is minus 1 here. 0 minus 1 is minus 1. Again 1 into minus 1 into minus 1 is going to give me plus 1. Minus 7 plus 1 is minus 6. And this 1 into minus 6 will give me plus 6. And this is going to become 0. This is your synthetic division method. I hope everybody remembers this. This into this should be written here. Okay. So after I do the synthetic division part, now I have d square minus d minus 6 equal to 0. So it is, these are the coefficients. So d square minus d minus 6 is 0, and minus 6 factorizes into minus 3 plus 2. So I'm going to get the factors as d square minus 3, sorry, d minus 3 and d plus 2 equal to 0. I hope I'm right. So I got the two roots here. D is equal to 3 and d is equal to minus 2. Okay. So how did I get d? Okay, I'm sorry. I should have written m everywhere. So this is actually m. So m is equal to 3 and m is equal to minus 2. Yes, sir, this is all by mistake. It should be m. Okay, so I got these two roots. Initially we had got first root is m equal to minus. So the roots are minus 1, minus 2 and 3. So m1 is minus 1, minus 2 and third root is 3. They are real, all the roots are real and they are distinct also. So my general solution y will become c1 e raised to minus x plus c2 e raised to minus 2x plus c3 e raised to 3x. This becomes the general solution of the given differential equation. Okay, so now let us continue with the next section. What we will do is we will derive some small result which will be useful for the roots if the roots are repeated. So let me just write result. So if I observe that I will leave 2-3 blank lines here to state what is the result. So let us take d minus a. Now what is the meaning of d minus a? D minus a means d by dx minus a, derivative minus a. And I will multiply this, I will operate this on e raised to ax y. So what is this meaning? I will just simply take this e raised to ax y to d and then I will multiply it to a. That is d of e raised to ax y minus a e raised to ax y, which is equal to, now what is the derivative of multiplication of two people? So this is derivative of u into v type. So first function as it is into the derivative of the second function plus the derivative of the first person is a e raised to ax into second person as it is y minus a e raised to ax y. But this a e raised to ax into y, a e raised to ax into y gets cancelled. And this becomes what? E raised to ax dy. This is my RHS. So I have obtained that d minus a e raised to ax y is equal to this. Okay. But if I have d minus a square, what will happen? So d minus a, but b minus a square e raised to ax y is equal to d minus a into d minus a e raised to ax into y, which is equal to d minus a e raised to ax into y can be replaced by the above person, which is equal to what? D minus a into e raised to ax dy. Okay, by the above step. Let me say by. Now I will again multiply this entire thing to d and then a. I will operate it on this. So d of e raised to ax dy. Dy means dy by dx, correct? Minus a e raised to ax dy. Dy means derivative of y, which is equal to, again this is product of two people, so I will have u into v rule. So first function as it is into the derivative of the second function. The second function is dy plus the derivative of the first person. What is the derivative of e raised to ax? A e raised to ax into the derivative into the second function as it is. क्योंकि मैंने पहले का derivative ले लिया है. Second function is dy minus a into e raised to ax into dy. But again, this person and this person gets cancelled. So this is e raised to ax into derivative ka derivative is double derivative d square y. So what have I observed? I have observed that d minus a square e raised to ax into y is equal to e raised to ax d square y. Okay, it looks very difficult, but when we are going to actually use it in problems, it will be very helpful. Okay, so right now it may seem very difficult, but it is actually a tool which we are preparing. We are trying to prepare a formula which will help me in my problems. So if I look at the first and the second observation now, the first observation is this and second observation is this. So d minus a e raised to axy is e raised to ax dy. D minus a square e raised to axy is equal to e raised to ax d square y. So what is our general observation? So the general observation will be d minus a raised to some power. If I take the nth power e raised to axy, it will be equal to what? E raised to ax d raised to n y. So that is our result. That is why I have left here 2 lines blank. So what is the general result that I'm trying to tell you? The general result I'm trying to tell you is that d minus a raised to some nth power e raised to ax y is equal to e raised to ax dny. Now you will understand this result. What is n? N can be some 0, 1, 2, whatever n. N is a natural number. You can take it from 1 also. No problem. So n is a natural number. So this is the result that, and how have we proved it? We will not say that this is proof, but we will say that we have verified this result. So I'm trying to give a brief justification or verification, I will say. Okay, and this is actually, this result can be proved using induction, but we will not do that part now. So this means that in general, if I try to do something like this, okay, if instead of using d minus a and all this, now what I will do is I will write the most general form of this particular result. So I will generalize this. So generalize. So this particular, so see how am I going to make it general? Let me just tell you. Okay, what was the previous result? It was d minus a raised to n e raised to axy is equal to e raised to ax d square d raised to n y. So I'm just going to replace this d minus a raised to n and d raised to n by fd. So I'm giving a more general result. So what will I write here if I want to replace this d by fd? Okay, I'm going to do what? This right hand side is going to come e raised to ax, okay, fd. This is your, I'm saying this is fd y is equal to, यहाँ पे क्या हो जाएगा, f d minus a e raised to ax into y. I'm just replacing what? I'm just replacing this dth power of n, the power d power n by fd. So d minus a को हम किससे, d minus a raised to n को किससे replace करना चाहिए? F of d minus a. I'm just replacing that. Okay. So again, we are not going to prove this particular result because it is an observation from the previous result, which can be again proved using induction. So, or maybe some linear combination of the above result. So don't worry about it. Now, what is important for me is that I want to take something special. Now, what is the special case? At the very first sight, this may look very, very difficult. Okay, but you know, when you solve problems, then you understand that it is actually very, very easy. So don't be afraid of all this. So put y equal to x power k. Now this k is want some relation of k and n. What will fd I will put? Instead of fd, I will put d raised to n. What will happen if I put d raised to n as fd and y is x raised to k? And what is the connection between k and n? The k should be starting from 0 and it should be 1 less than n. It should mean it should go from 0 to n minus 1. You know why I'm doing this? You will understand in a couple of minutes. So just substitute, just replace the above variables. Therefore, above result becomes what does the right hand side become? E raised to ax fd. What is fd? Fd is d raised to n y. What is y? Y is how much? X raised to k. And what is the left hand side? This is e raised to ax into x raised to k. And what is f of d minus a? F of d is d raised to n. So what is f of d minus a? When d charge agi, instead of d you just write what? D minus a raised to n. So d minus a raised to n. Okay, this is f of d minus a. Okay, is this very confusing? Is it very difficult? No. Now the right hand side is actually what? Right hand side is actually 0. Why it is 0? Why right hand side is 0? Because e raised to ax into what is the nth derivative of x raised to k? What is k? K is between 0 to n minus 1. So k is less than n. K n se less hai. If I ask you what is the fifth derivative of x cube? Okay, this is like asking the higher derivative of a smaller person. So we know that x cube ka derivative is 3x square. Uska again derivative if we find out will become 6x. Again if you find the derivative will become 6. And again if I find the derivative, the higher derivative will become 0. So the higher, why? Because n is large, right? n is large, n बड़ा है, इसके बाद n आता है. So k कहाँ तक जा सकता है? At the most n minus 1 तक जा सकता है. So उसके आगे का डेरिवेटिव अगर मैंने लिया तो क्या हो जाएगा? 0 हो जाएगा. So dn x raised to k will become what? Will actually become 0, right? Since nth derivative of x raised to k is equal to 0. Why? Because k is what? K is smaller than n. Easily. Right? So I know that 4 is smaller than 6. So what is the sixth derivative of x raised to 4? If somebody asks you, you will say that the sixth derivative of x raised to 4 is how much? 0. So I'm getting that, therefore d minus a. I know this is very tough to understand at the very first sight, but we are not going to use all these things in actual problem solving. While actual problem solving, I will just use the result. This is d minus a raised to n is e raised to ax x power k, and this line is very, very important for me. Okay, so this means that what are the values of k? What are the values of k? K I know is 0, 1, 2, 3 dot 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 up to n minus 1. So put k equal to 0 if in this part. So if k is equal to 0, this means that e raised only in this part, e raised to ax k x power k is 0, so 1. So this is e raised to ax. Put k equal to 1, x, k equal to 2, e raised to ax x square dot 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 e raised to ax into x raised to n minus 1. Okay, I'm putting the values of k in this part. Are solutions of which differential equation? Using seeing this line, which differential equation you think it is? D minus a raised to n y equal to 0. So these are all the solutions of this particular differential equation. Okay, I will quickly repeat and come up to this step. The calculations that we did is that initially we started operating d minus a y on e raised to ax y. We observe it as d square a e raised to ax dy. When you took the square, you got a d square, and therefore in general I declared that d minus a raised to n e raised to ax y is equal to e raised to x nth derivative of y. Fine. Okay. Now here also I'm going to replace this d minus a and d by more general terms. I'm going to say it fd means some anything in d, polynomial in d, which is this general result. Now when I take the special case of that, the special case is I'm taking y equal to x raised to k and fd I'm taking d raised to n. Just replace those quantities in the above result. You will get this, and then I understand that the nth derivative of x raised to k is 0. So this result is giving me that d minus a raised to n y e raised to ax equal to x raised to k is 0. When I put k equal to values from 0 to n minus 1, I'm getting that e raised to ax, e raised to ax x, e raised to ax x square up to x e raised to ax x minus 1 all become those solutions of this differential equation d minus a y d minus a raised to n y equal to 0. Now the time is that I want to apply this and solve a problem. Only then you will understand that what we have done above was so easy. Okay, let us take a very simple question so that everything will be clear. Solve d2y by dx minus 2 dy by dx plus y equal to 0. We are going to find the general solution of this differential equation. Let us write it in the terms of our usual habit, capital D. So what is this? D square minus 2d plus 1 y is equal to 0. So this means that if I write the auxiliary equation, fm is equal to what? M square minus 2m plus 1 is equal to 0. So I'm getting this is m is equal to, so this is m minus 1 into m minus 1. Basically the factorization is m minus 1 into m minus 1 is equal to 0. So the roots are what? The roots are m equal to 1 and 1. So now they're real also. Yes, they're real, and now they're not distinct, but they are repeated. So I cannot use that formula c1 e raised to something, c2 e raised to this sense, right? Because the roots are what? The roots are repeated. But if the roots are repeated, so you see that the above question can be written as what? D minus 1 whole square y equal to 0, correct? Because it is the roots are repeated. So you can write it in the fashion of d minus 1 whole square equal to 0. And then I will use this result. What is this result now? See this. D minus 1 square. So n is equal to 2. Correct? In this formula, n is equal to 2. And who is value of a? Who is playing the role of a? Here, role of a is 1. So in this case, if n is 2 and a is 1, what are the solutions? The solutions are e raised to ax, e raised to ax x, e raised to ax x square, and so on up to e raised to x ax x raised to n minus 1. So n will take maximum value 2. So what will I write? The above list will become, therefore the solutions are e raised to ax and e raised to ax into x, only 2, because last one कौन था, e raised to ax into क्या था, n minus 2, n minus 1 था, n की वैल्यू कितनी है, 2 है, so e raised to ax into x raised to 2 minus 1, मतलब x raised to 1 तक ही जाना है, we have to go till only x raised to 1, so I've stopped up to x raised to 1. So how many solutions I have got? I have got 2 solutions. But I know, therefore, what is the general solution? Therefore, the general solution is y equal to c1 e raised to a. A का value कितना है? A is also 1. c1 e raised to x plus c2 x e raised to x. The second part. First solution, second solution. Okay. So do you observe what is the small change that has happened? Because that root was repeated 2 times, what is this the general solution? हम ऐसे नहीं लिखेंगे c1 e raised to x plus c2 e raised to x नहीं लिखेंगे, लेकिन repeated होगा तो you just, it means you just put a additional x over here. Okay, so I hope this is understood. Let me take one more example so that it will get more clear to you. So take a question saying that solve dy by dx minus y whole cube, sorry, d cube, let me take it like this, d minus 2 cubed y is equal to 0. Okay, so what is the solution of this particular differential equation now? Clearly it is auxiliary equation is what? Auxiliary equation is Fm is m minus 2 cubed equal to 0. So this has 3 roots. The 3 roots are m equal to 2, 2 and 2. So real and repeated. So what is the general solution now? C1 e raised to 2x plus C2 e raised to 2x plus C3 e raised to 2x. Here I will put a x and here I will put a x square. Okay, this is what we have learned, right? E raised to ax into x raised to nothing, then e raised to ax into x, e raised to ax into x square. इसको add करते करते जाना है, एक term come automatically, you will stop at the x squared power. Okay, let me take one more example. I'm still not convinced that you people have understood. So let me take one more example. Suppose question, solve d3y by dx cube plus 3 d2y by dx square plus 3 dy by dx plus y equal to 0. So how will I do this? So this means that it is d cube y plus 3 d square y plus 3 dy plus y equal to 0, which is d cube plus 3d square plus 3d plus 1 y equal to 0, which is nothing but d plus 1 cube. This is the formula of d plus 1 cube, y equal to 0. So this means that the auxiliary equation Fm is equal to m plus 1 cube equal to 0. This is the auxiliary equation, and therefore what are the roots? M is equal to minus 1 minus 1 minus 1 3 times, real and repeated. So what is my general solution in this case? C1 e raised to minus 1x plus C2 e raised to minus 1x plus C3 e raised to minus 1x multiplied by x here multiplied by x square here. This is the general solution. Let me just make a slight change, a slight complication now. Solve d plus 1 into d minus 2 d minus, let me take d minus 3 square y equal to 0. So now I'm solving this particular differential equation. Now directly it is given in the format of d, so I will write what is the auxiliary equation. Auxiliary equation is what? M plus 1 into m minus 3 square equal to 0. So what are the roots here now? Now you see the roots are, some roots are different and some roots are repeated. Okay, so here you have to take the combination of that. दोनों अगर different होगा, suppose I get two distinct roots, m1 and m2 are distinct roots, अलग अलग roots होगा, तो c1 e raised to m1x, c2 e raised to m2x. This is what I write for different roots. Repeated होगा तो हम x लगाएंगे, x square लगाएंगे और ये story हम continue करते हैं. Now in this particular example, what is happening? You are getting roots is minus 1, which is different from other people. What are the other two roots? 3 and 3. So these two are repeated. But in all अगर देखा जाए तो 1 and minus 1 and 3 वो क्या हो जाएगा? Distinct roots होता है minus 1 और 3. So minus 1 और 3 के लिए अलग formula लगाएंगे. So what means what will I do? C1 e raised to minus 1x, C2 e raised to 3x plus and C3 e raised to 3x. अभी ये तो डिस्टिंक्ट है, इसका क्या, इसका तो यहीं पे काम खत्म हो गया. यहां से मैं रिपीटेड का देखूंगा कि नाउ दीज आर टू रिपीटेड रूट्स. सो शुड आई अटैच x हियर एंड x स्क्वायर हियर? इज दिस करेक्ट? और शुड आई ट्रीट दिस एज अ फ्रेश? So hide this for some time. So if you hide this for some time, this root is repeated twice. So what should I do? Should I write a x here and a x square here? No. Now this will be first component को हम कुछ भी नहीं लिखते. देखो first इसको we don't write anything. Right here we see, here we have not written anything in the first person. Second term से you start multiplying x and x square. So here the first person will be untouched and the x will multiply to the second factor. So right, so I hope now this confusion is clear. So distinct के लिए वो अलग है, इसका इन दोनों से कोई relation नहीं है. So this will be the general solution of this particular differential equation. Now we will take a last question now and then we can stop. So solve the differential equation d minus 3 square into d plus 4 square y equal to 0. Now I hope you can write it on your own. So what is the auxiliary equation here? So auxiliary equation fm is equal to m minus 3 square into m plus 4 square is equal to 0. So the roots are m equal to 3, 3, 4, sorry, minus 4, minus 4. So what will I write for the solution? The general solution will be c1 e raised to 3x plus c2 e raised to 3x. इसका repeated आ गया, so यहाँ पे x plus c3 e raised to minus 4x plus c4 e raised to minus 4x. इसका भी repeated आ गया x. So this becomes the general solution of this differential equation. I hope that the solutions, how to write the solution, general solution for the roots if the auxiliary roots of auxiliary equation are repeated is now clearly understood.